So how do I find the percent composition of each element here inside of barium oxide? Well, first thing is I got to find the total mass of barium oxide, so let's use this table to help us out. Bam! So the first thing I'm going to do is write down the elements in barium oxide. So I have barium and I have oxygen. Next is to then write down the number of atoms, right? So that's where the subscripts come into play. So at the bottom of barium, there is an invisible one, so that means there's one barium. And then the same thing for oxygen. There is a 1 down there as well, right? So there's one oxygen. Then take those number of atoms and multiply it by the mass of each element in barium oxide. So we need the periodic table for this, right? So we look at the values here. Barium is about 137.33 and oxygen is about 16. Those values represent either gram per mole or AMU. All right, depending upon if you're finding molar mass or molecular mass. The magnitude of those values are the same. The units are definitely different, but the magnitudes, the numbers are equivalent. So let's plug in now those masses. All right, so for barium, it was, as it mentioned, 137.33, and oxygen is about 16. All right. If you're using a different periodic table, the numbers might be slightly different. That's just because of rounding. So next, to find the total mass of the element now in the compound, we're simply going to multiply the row here. So each barium is 137.33 units of mass. I only have one of them, so that means a total of 137.33, right, for barium. And same thing for oxygen. Just multiply that on across, so that's 16. And then finally, to find the total mass of the compound, you're simply going to now add up this particular column. So the total mass now of barium oxide is going to be 153.33. Now this was the first part to finding percent composition. All right, we had to find the total mass. Now it doesn't matter if you use gram per mole or AMU, it doesn't make a difference. I'm going to leave the units out just to keep it simple. All right, but what I do need is I'm going to add another column to this table to simplify the process. Bam. And now in order to find the mass percent, all we're going to simply do is take the total mass of that particular element, barium in this case, 137.33, and just divide it then by the total mass of the entire compound. Hence why we needed to find that first. 153.33. And this is a basic percent formula, right? It's part over whole, okay? And multiply it by 100. All right, and that will give us now our percent. So when we calculate that, the value is going to work out to be about 89.56%. That's the percent of barium in barium oxide. Now you're going to do the same process for oxygen. You're going to take the 16, divide it then by 153.33, multiply that then by 100, and your percent is now going to work out to be about 10.44-ish, okay? Right, considering the rounding, 10.44. Now, all you need to do just to make sure we're good, right, you can add these percents up and it should equal 100%, right? Just a little simple check. By the way, just because it adds up to 100% doesn't mean you are totally correct, because we might have improperly calculated these masses, all right? So, you know, but it is a good check. It'll tell you if you did screw up here, at least. But it might not tell you if you screwed up here. All right? But anyway, you know, sure. Guys, thanks so much for tuning in. I appreciate it. I really do hope it helped. And if it did, like, subscribe, tell your friends. We'll see you in the next one. Take care.